a new channel on Slack called ML Bootcamp or something like that. It has a video link to it. All right, so we were just debating, how many alarms do you set in the morning?
A lot.
Like, how many is a lot?
We need a count on
More
this.
than normal.
We need like an exact count.
I mean, they said it might be like 40.
No, probably not.
But they're all on your phone?
Yeah.
So, I mean, it sounds like if you have issues getting up, you need to have like an alarm like across the room.
Well, I do. I have one.
Or do they sell like alarms that like, you know, like provide like a non-lethal kind of a non-lethal kind of shock type of situation?
Didn't he set alarm in your room?
You just put like contact points on you before you go to sleep.
Or it's like one of those you know, just a giant like Gatorade bucket or something like that. It's like, you know,
Every alarm that goes off is explosion.
and it finally just dumps on you. So your motivation is you get up before the alarm, otherwise you're gonna get like a giant barrel of stuff dumped on you at the end of. Even if it dumped on you?
It's cold and damp now.
Wow.
Why? I'm going back to bed.
So, well, that's the worst that could happen. It's already happened. So you just roll over and go back to bed. All right. So we've been looking at Android stuff. So just to quickly review this. We were talking about iOS versus Android. We started talking about this idea of something called a layout. So this is a tool for organizing things on the screen. If you remember from last time, we were working with our layouts here. And need to get it. Well, it's interesting. This says there's nothing to show. I'm going to let it reload that. There we go. All right, so when you come into your XML document for your layout, it shows your component tree down here. Notice we have this vertical linear layout that's in here. So anything we throw inside of the vertical linear layout gets stacked on top of each other. So there's our app name. Here's this horizontal linear layout that has these 3 buttons in it, but notice, and then we have another text view underneath that. Just says text view. So we have 3 individual components all inside of this vertical linear layout. So anything we throw in there just gets stacked on top of each other. All right. Now we have a horizontal linear layout here, and anything gets thrown inside of that gets stacked next to each other. So inside here we have 3 buttons that are sitting next to each other inside of that horizontal linear layout. All right, so we're going to build most of our interfaces just using vertical and horizontal linear layouts to give us simple kind of interfaces. All right, so we use layouts to lay out aspects of our interfaces. And I also mentioned here that programmatically, and we'll see this in the next week or so, a layout is represented as a view group. Okay, we've just started looking at how do we accomplish MVC to get aspects of our interface available to us in code, and we're going to see vice versa today. But when we go to access a layout, we're going to be accessing it through a variable type called a view group. All right. We talked about views. This is anything you see on the screen. So right now, like for instance, a text view is one of our views. I'm going to go ahead and add to this list since we've also thrown buttons on the screen, even though we haven't made them work yet. So this guy is a clickable button that calls the function associated with its onClick property. And that's what we'll be looking at today. All right, so view is anything we see. Attributes, these are things associated with a view. I called it a property here. We'll change it to attribute just so those match up. All right. We talked about the gravity attribute a little bit. This kind of idea is anytime you have a layout, or actually anytime you have any sort of view, there will be a gravity component associated with it. So, for instance, this top level vertical linear layout here that all of my stuff in this screen is associated with, it has a gravity attribute over here. Okay, so when I select that vertical linear layout, I'll see under attributes, we have gravity. If you don't see gravity sitting there, what you can do is you can go down to the bottom here and say view all attributes, which will give you this giant list of attributes and find gravity in there because this just kind of gives you the ones that are most commonly used. So I'm going to click on gravity. You're going to see it gives me a big list of things that I can have. I'm going to go ahead and I'm going to center vertically. So what I'm effectively doing is inside of this layout, that is my vertical linear layout, I am turning on gravity in that atmosphere. Okay, so anything that lives in there will now be impacted by gravity, which will suck everything to the center vertically of the screen. Okay, so that should move it all to the middle. That makes sense? If I set it to bottom, all of it gets sucked to the bottom. If I set it to top, it stays right where it's at. That was the default gravity. All right. Does that make sense? So we can set the gravity, and anything inside of that pod and anything inside of that container will now be impacted by that gravity. Okay. So let's assume that I go ahead and I set the gravity to center vertically, but then I click on one of my views here. So like this button that's called that says LOL, and I go ahead and I'm going to set the gravity for that guy to be left. So even though he lives inside of a larger container, so that's why he's sucked to the middle here, he has his own gravitational field, if you will, that governs what lives inside of him, and I set that gravity to left, which sucked it over to the left.
What if went down?
You mean bottom?
Yeah.
So a little bit of a change. But you can mess with those kinds of things to get your layout looking the way you want it to look. You know, again, it's kind of a trial and error, artistic type thing. We're not going to spend a ton of time with it, but you know, at the high level, do we get what gravity kind of does? Mm-hmm. Okay, so anything that lives inside of a container is impacted by the gravity of that container. So I'll go ahead and turn my gravity back off here to get it back to the top. Okay, so we talked about this idea of an activity. So activity we can think of as being any screen in our application. Okay, and something gets called one time in this activity, and that's this thing called onCreate. All right, so even though we have a bigger activity life cycle than what we've seen so far, the first moment we have to work with our activity is in this function called onCreate, which does get created for us. So if I go to the controller here, let me scoot this stuff over. I go to the controller here, I see that I have a function that's automatically created for me called onCreate. Okay, what onCreate does is it first calls its parents onCreate, doing some stuff. Don't even worry about what that does for right now. But it also sets the content view. I'm going to say this dot before that just because that's the way I like to write it. So I'm saying I'm going to take this activity. I'm going to set his content view equal to activity main. And that's this dude right here. That's what will make that screen look like this screen. All right. So this is kind of an example of MVC. I'm taking a controller and I'm taking the interface and I'm saying this controller will display this particular interface. Okay. Now we saw last time, let me go back in here just to remind us of this. I took this bottom text view.
Can you say again, what is the set content view?
Set content view, this guy makes the screen show up with this. If an activity is a screen in our app, setting the content view of that screen will make it look like the thing we set it to.
Oh,
So it connects the two dots there.
so basically you said that the main view is like the whole thing with the first app LLL thing, like the whole thing.
Yeah, well, this is the screen I've designed here. Okay, so this is the screen. This is what I want my app to look like. This is what I want my app screen to look like. My current app only has one screen. I have one activity. So we can think of an activity as being a screen in our app. And I want this particular screen in our app to look like the layout I've defined in here, which is this guy right here. All right, and this will always be done for you, but if you ever want to change your layout to a different one or something, you can go and set the content view to something different. Okay, so back over here in my interface builder, I created a text view that I put my first app in by default, and I went ahead and gave this guy a name. So I gave it an ID called app name TV. That's like associating a variable name with this particular widget. Okay, so this is a text view that I see on the screen, but at the same time, I'm going to want to access it from my code. Therefore, I have to give it a name, a variable name that I could find. So then in code, so this guy's called app name TV. So if I want to get that text view right here, so I'm going to create a variable of type text view called app name TV. I could have named this whatever I want. This is just a normal plain Jane Java variable. It just happens to be capable of holding a text view instead of an int or a string or a char. This guy holds a text view. And I'm setting this app name equal to something. Okay, I'm going to rewrite this part here just so I can talk about it as I'm doing it. So we have a function here of an activity that allows an activity to search itself for a particular view. So back out here, as a reminder, this particular view we gave a name app name TV. So that's the name of that view. So I go back in here, I'm going to ask my activity, so that's this. This is this instance of the activity class, dot find view by ID. I'm asking the activity to go and search for a particular view. What view? r.id.appNameTV. All right, now even though it's not required, I like to write this by putting a text view in front of it. Because technically what comes out of here is a generic view, even though we happen to know it's actually a text view. So a view is anything we see on the screen. A text view is that plus a little bit more. It allows us to set the text of it, change the font, stuff like that. All right. So I happen to know that the view with the ID app name TV is actually a text view, not just the generic view. So I'm going to go ahead and tell Java here that go ahead and convert that generic view into a text view and then store it in this variable. Now the reality is that was happening anyway, because this view, when we stored it into a variable of type text view, it did the conversion for us. Arguably, this could make it a little quicker by us making that decision for it. Arguably. Realistically speaking, the compiler under the hood probably goes ahead and makes that change for us. So it probably didn't matter if we wrote it or not. Yeah.
Can you talk about this dot again?
This part here?
Yeah.
Well, so what's the this keyword? This is how an object refers to itself from within itself. That's not an Android thing. That's a Java
So
thing.
it's just like self in Python?
It's self from Python. Yeah, self from Python, and we use in Java we say this dot. All right. So when I say this in this context, this is this particular instance of activity. Technically, it's an app compat activity, which is an activity.
Question. So I didn't see you mention it above. So how would it refers to itself on this?
This gets created for us. We've seen the this keyword before, right?
Yeah, you
This is No,
I
we.
don't know
we
if
have.
we've ever used it, but I've seen it.
Yeah. Well, so this keyword gets created for us. That's part of how Java works. Just like in Python, the self keyword gets created for us. So we didn't have to define this; it came with our code. All right, this guy came with our code. There's no way we didn't. Didn't we write like a dice roller and stuff like that?
Because here's the
Java?
question. Like I
In
feel like
Java.
I don't
sometimes
think we've used it.
we use this,
Not
sometimes
Java.
we don't for like certain things. I mean, not everything we use is put a this in front of it, isn't it?
I'm gonna check something here.
Did all the dice roll stuff last year.
Yeah. But we rewrite a lot of that stuff in
Java.
Oh yeah, we have.
I think we did some stuff in the book instead for when we were gone.
And this keyword isn't introduced in the book? It
We
has to
only
be.
use the book for arrays.
Yeah. Focus on those.
So this was us, right?
Mm-hmm.
So we talked about it, but maybe I didn't go into great detail. That's fine. I'll talk about it again. Go ahead.
So is like this defining the function at the same code line, just that one code line, or is it?
Well, let me review this because it's a pretty important concept. Have I really not talked about it? Yeah. Okay. Well, let's talk about this then for a second. So the this keyword this is the same as self in Python. It is how an object refers to itself from within itself. And in last semester, when we introduced this, we would have had a thing that said self keyword, and we would have said this is how a Python object refers to itself from within itself. So same definition. All right. So it is automatically created for us in Java. Well, let's see, for us by a Java constructor. All right. And remember when we talked about constructors, we said that they're always going to have the new keyword in front of them, right? So the new keyword always goes and gets us when we build a constructor. When we use a constructor in code, it's always going to have the new keyword in front of it because it's always going to return for us a memory address. Constructors themselves don't actually have a return type because the return type would always be the same. So Java has allowed us to omit that return type. What it returns is a memory address, a pointer, and that pointer's name is this. That's what it ultimately returns. All right, so this keyword gets created for us by Java. So in here, oh, wrong guy here. When the app compat activity, this guy here, when he was first created, he generated a variable called this. Just like in Python, we generate a variable called self. And when I say this in here, I'm talking about the particular instance of app compat activity that was launched here. I don't have access to that variable name though. Someplace else in my program, somebody maybe created a app compat activity called main screen and then made it show up on the screen. Well, I don't have access to that variable called main screen in here. The only way this variable can talk about himself is by saying this. That's like when I say me or I. Okay, that's me talking about myself. It would be weird if I said Mike. Okay. Well, Mike did this and Mike did that, then it's like weird, right?
Talking to the third person.
Talking to the third person, right? But with us, it's technically legal. With this, we don't have access to that variable. Okay, so I don't actually have direct access to my name in Java. So we use this generic variable called this, which holds a memory address, which is how an object refers to itself from within itself. So when I come in here and I say this dot, I'm saying I want this particular instance of app compat activity to call his set content view, and I want him to set his content view to this guy. All right. Technically, the this dot is not required here because is this guy a class method or an instance method?
Core.
Instance method.
Instance method, no static. Okay. Instance method, no static. Okay. At this point, where are we at? Week 9 or 10? Week 10? Okay. That should be instantaneous response. So if it's not instantaneous for you yet, when you just glance at that and have the response, then you're behind where you should be. All right, so get that straight in your mind. The first thing you do when you see the definition of a method is static there or is static not there? That's a pretty quick thing to see, right? Okay, if static is there, it's a class method. If static is not there, it's an instance method. Okay, quick. Then from there, you ask yourself, well, how would I call one of these guys? Then you can say, okay, well, if it's an instance method, I call it with an instance of the class in which it was defined. If it's a class method, I call it with the name of the class in which it was defined. So since this guy is an instance method, I am operating, we would call this guy actually, the way it would officially be referenced is as a non-static context. But we can say maybe it's an instance context. But the official object-oriented term for this would be a non-static context. So let me add something to the notes here. What does the word context mean? So in real life, if somebody asks you a question and you say, well, can you give me some context? What do you mean?
The description of the scenario.
Yeah, give me the scenario. You know, there might be 5 different answers you can give. It really depends on the scenario you're talking about, right? All right, so context really, I like that description. So context is really the scenario in which we are operating, something like that, okay? That's what a context is in real life. Now, since programming languages attempt to mimic what we do in real life, it would follow that context inside of a programming language would indicate the scenario in which we're writing our code. Okay, so we might say this is for programming, this is the scenario in which we are writing our code. All right, so that's what a context is. Now, types of contexts. When I say we are in a static context, that means that we are within a static method. Therefore, it is presumed, therefore, the class name is presumed to be in front of variable and method calls associated with that particular class. In a non-static context, we are within a instance method. Therefore, the the this keyword is presumed to be in front of variable and method calls associated with this particular class. Okay, so when I say non-static context, I'm talking about an instance context, but you will probably rarely see it referred to as an instance context. You'll see it as either a static or a non-static context, which lines up to our idea of do we see static or do we not see static? That make sense? All right, so really, I mean, I know I keep saying it, but I cannot emphasize the importance of getting that straight in your head, being able to immediately differentiate between a class method and an instance method. Super, super important, and you're going to have a lot of trouble reading documentation forever if you don't get that straight in your head. Okay. So when we talk about the context, as far as programming goes, we're really talking about the scenario in which we're writing our code. So if we go back into here, because this guy is a non-static method, the context we're dealing with here is a non-static context. And what did our slide say? It said that it is presumed that the this keyword is in front of method calls and variable names associated with this particular class. So I'm telling you that main activity received a set content view. So if I, here, let me just show you this real quick. Just be, so I'll go to the documentation for app compat activity. So this is the Android documentation. So here's an app compat activity, which is actually a fragment activity, which is actually an activity. All right. Now, which is actually a context theme wrapper, which is actually a context wrapper, which is actually a context, which is actually an object. So if you remember back from last semester, when we kind of showed the object hierarchy, when we built like a dice object, we had object and then we had our dice object. Okay. This is that same thing, just more layers, right? So we have this guy, which is actually one of these, so he inherits all the stuff associated with this guy, which is actually one of these, so he inherits all the stuff associated with this guy, which is one of these, which is one of these, which is one of these, which is one of these. Okay? So all that stuff kind of spills through. So down here, if I scroll down, we should see the set content view. So there's going to be a function called set content view defined somewhere in here. I don't know which of those levels gave it to us, but we will find out here pretty quick. Here we go. Set content view is actually something that comes from app compat activity. So it's a local function here. So here's my set content view, and here's the version that takes a layout ID. So we'll talk about that here in a second. But is this guy a class method or an instance method? Instance method. How do you know?
No static.
No static. How do we call instance methods? By an instance of the class in which it was defined. And we're looking at the documentation here for app compat activity, that class name. Inside here, I have an instance of app compat activity. His name is this. But since we are currently sitting inside of a non-static context, it is presumed that this dot is sitting in front of that set content view. It acts like that's the case. Okay? But if I don't put the this dot keyword explicitly there, what it will do first is when I try to call this function name, how do I know I'm calling a function here? How can we tell that that's actually a function call? Parentheses. Okay, so since we see the parentheses there, this guy must be a function call. And what we're going to do is we're going to look locally here first. Do I have a function that I have defined in here called setContentView? We have one function called onCreate, right? So I haven't defined a function locally called setContentView. So then the next place it'll look is one level higher, my parent, which is app_compat_activity. And didn't we just look in the documentation and find that there is indeed a setContentView function in there? So when I say that this class, main activity, which I'm writing right here, extends app_compat_activity, I'm saying that I'm creating some new code, but my starting point is everything that an app_compat_activity is. So give me all his stuff. And give me all the stuff that he got from his parent, and all the stuff that they got from their parent, and so on and so forth. We just saw the big hierarchy, right? So I get this big collection of stuff that I don't see on my screen here because it actually is housed, it's encapsulated inside of app_compat_activity, and then some. But I actually did get access to this function. And we saw in the documentation that that particular function is an instance function, an instance method, right? Because there was no static. And how do I call it? I call it with an instance of the class in which it was defined. So I need an instance of app_compat_activity. Now, inside of here, I did not specifically define an instance, but as we were talking about the this keyword, I mentioned that this keyword is automatically created for us. And it refers to an instance of the class that we are currently sitting in, which is an instance of main activity, which happens to be an app_compat_activity. All right. So even though I'm in a non-static context and I don't actually have to put this dot in front of here, I like to use this dot for multiple reasons. First, so I don't have spelling issues, because it'll go ahead and do the command completion. If it didn't put that line in there for me, I could have said this dot set content view, found that guy right there, pressed enter, it would have spelled it out for me. I don't have spelling errors, all that stuff, so it's helpful in that particular case. It also arguably makes the code faster, because depending on how the compiler actually turns this code into low-level code, it might actually do a scope search in order to find that function called setContentView. And if I specifically say this dot in front of it, I'm giving it kind of the full path, the best place to look. You will find it here. All right, so I'm letting it be a little quicker. All right, so I like to put this in front of it, but that kind of goes back to whether or not you sometimes see it, you sometimes don't. When I write it, you'll always see it in front of it. But it's pretty common when you look at other people's code, if you are sitting inside of a non-static context, they will not write the this keyword. That's probably more common than writing it.
Is there a situation that they require to have this in front of it, and there's a situation that not required, or if you put the this in front of it, the code will not work?
Yeah, so let me... Let's just write something here in, well, we already have it. So in Java, if we wrote a class called letter, all right, so I'm creating my own class called letter, and we have a little invisible thing here that actually says extends object. Okay, so a letter is actually a generic object, even though this is assumed to be there if we don't specifically inherit from anything. And we've decided that a letter will have a weight associated with it. Okay, and it's also, we also put this private double postage, whatever, in here. So we have a weight. Here's the constructor for our letter. How do we know this guy's a constructor?
That's public.
No, lots of things can have public in front of them that are not constructors. How do we know it's not a field?
Oh,
How do we know it's not a field? Go ahead. How do we know it's not a field?
No person.
How do we? Because it has parentheses. Fields do not have parentheses, therefore we know it's not a field because we have parentheses, right? So if it's not a field, it must be one of the two other guys, either a method or a constructor. How do we know this guy's a constructor? Go ahead. Same name as the class. Class name is letter. This guy's name is the same as the class name, must be a constructor. Go ahead.
Will it then be like capitalized? The first letter will be capitalized?
If this is capitalized, then this one will be capitalized. Must match identically. Okay? And then the other thing you could have said is it's also a constructor. If we know it's not a field, it's a constructor because it doesn't have a return type. Remember, functions, methods have return values, right? Might be void, but we always have to provide the return type for a method. Why is there no return type here in front of this guy? We've already determined it's a constructor. Why do constructors not have return types? I've already mentioned this today. You act like there's so much information you're having to absorb here. That's why we keep repeating it over and over.
I'm gonna take a guess. You want a visual representation for it?
What's the return type for a constructor always going to be? Constructors, when we call a constructor, we always find it, so here in driver, for creating a instance of our letters here. So if I say letter L is equal to a new letter, my constructor takes a double weight as a parameter, so I'll pass it a 1.11, something like that. So here's the constructor being called, right? We always have the new keyword in front of a constructor. What's the new keyword? Real estate agents. What is the new keyword always boil down to? Technically it would be new, I guess. What does it ultimately give us a value of? Memory. Always gives us a memory address, right? So if we are always using the new keyword in conjunction with calling a constructor, the constructor will always be responsible for producing a memory address. Okay? So it'll always be responsible for producing a memory address. Now I'm going to show something here to drive this point home. So I'm going to comment out this other stuff here just for the moment. All right, so here's our letter L. So I have an instance of the letter class. And I'm going to go ahead and do a system.out.println L. What's going to print out here? A memory address. It's going to print out a memory address associated with this variable L, which is a memory address which points to an instance of letter in memory somewhere, right? All right, so I'm going to go ahead and run this real quick, just so you see this. All right, so there is our memory address for a letter. Might be kind of tiny on there, but trust me, it says letter at 6073F712. Memory addressy thing. Okay? Now I mentioned that this keyword is automatically created for us in the constructor, right? All right, so out here, I'm calling upon my constructor. Here's the constructor. What does the constructor do? It takes in a weight, it sets the weight, and then I'm going to go ahead and just print out the value of this. A, proving that this exists. It got created for us. But I'm also interested in what the value of this is. And then what am I doing out here? I'm printing out the value of L. Okay? And we're going to see that they're the same value. They're synonyms for each other. Here's the first one is the value of this. The second one is the value of L. They both hold the same memory address. So let's connect the dots here then. This is how an object refers to itself from within itself. Inside of this class, I don't have access to that variable called L. That variable L lives in the scope over here in my main of driver, right? So I created this variable of type letter here, and I happen to store it inside of I created an instance of type letter, and I happen to store it inside of a variable called L. I have access to L out here from this point forward inside of main. It's a local variable of main, so its scope is local to main. If I'm inside of the letter class and I want to refer to this particular instance of letter, the instance that's stored inside of L, I don't have access to L in here. If I say L dot, it doesn't know what I'm talking about. It says there is L cannot be resolved. Doesn't know about a variable named L. So if a instance has to have the ability, if we'd like to have the ability to refer to ourselves, we have to have a special variable that's automatically created for us to do that. And that variable is called this. All right. So this is how an object refers to itself from within itself. And we've proven that by printing the value stored in the variable external to the object as well as internal to the object. And we see that they both point to the same memory address. That make sense? Go ahead.
So this might not make sense, but couldn't you, like, can you go to the other one where you go L? Couldn't you, like, define, like, another letter? And then,
Yep. So let's call this guy letter L2 is equal to new letter 2.11, whatever.
so how would you access that?
Here, I'll show you. I'm just going to print these in the right order. That way we can see it happen. All right, so when I build L, we know that this constructor is going to print the value of this, correct? That's what this constructor does. Every single time we build a letter, it's going to print the value of this. That happens every single time we build any letter. So out here, I'm building two letters. I'm building a letter right here. I'm building a letter right here. So two separate letters are getting built. Both times, this keyword will get printed out. But they are distinct keywords. Okay, this is how an object refers to itself from within itself. So in this constructor, this will get printed out. And then right afterwards, I'm going to print out the value of L. Those two memory addresses should match. Then I'm creating a second letter, which will give us a different memory address. And this guy will also print out this, but it'll print out L2's version of this, which will be the same memory address as L2. So if I run this, these first two are the same. These second two are the same. So this inside of this particular constructor is the same value as L2 ultimately holds. Whereas this inside of this instance's constructor, even though it's the same constructor, holds the memory address that L will ultimately hold. So this is always how a particular instance of an object refers to itself from within itself. For instance, if I say me, I'm referring to myself. If Blaine says me, he's referring to himself. We are both instances of human. Okay? Make sense? Got very robotic there, but it's a true statement. Okay? We're both instances of humans. Okay? This is my way of saying me. When he says this, it's his way of saying me. But my this is different than his this. And we'll throw Christian worldview on it. That's soul. That's our soul, right? That's the point. Christian worldview point, yeah. All right, so go ahead.
Can you put system.out.println and then put this, and then this automatically refer to L?
You mean out here?
Yeah.
No, we don't have a variable called this out here.
Just kidding.
Yeah, so it's going to tell us that we don't have a variable called this out here, because notice it says cannot use this in a static context. So since this guy's a static context, this is not a constructor. This gets produced by a constructor. This keyword gets produced by a constructor. A constructor was not involved here. This is just my public static void main, my normal thing that drives my program. I don't have an instance of a variable. I don't have an instance of an object here. This guy doesn't represent an instance of driver. Therefore, this keyword was not created. So I don't have access to it out here. Where in this case, this is a instance context creating, and this is also a constructor which creates the this keyword. That's what he does. That's his job, is to create the this keyword. Yeah.
So in this.
Which one?
Yeah, go back to it. So in this one, what this is it printing? Like, how does it know? You know what I mean?
Okay. We're gonna do. All right. So Blaine, you get to be our first letter. All right. So when we create Blaine, you should probably stand up for this because there's going to be a dance. Okay. Okay. So right there, I've created my first Blaine, my first letter. Okay. My first Blaine. Okay. It's a work in progress, people. So I've created my first letter. Now, if he were to print out this, he's printing out himself. Okay.
This is me.
Yeah. Now, if I then come down to this line and I'm asking another letter to get produced and he prints out his version of this, he's referring to himself. Remember, an object here, this guy, is a blueprint. We are using this to build multiple instances of letters. This instance of letter has a this keyword. That instance of letter has a this keyword. They both mean the same thing in that they both are a way of referring to themselves from within themselves, but his instance of this knows about him. His instance of this knows about him. So we use this one blueprint to create two separate letters, one here, and inside of these constructors, we are printing out the this keyword associated with that particular instance. So in our first case here, this would be Blaine. That makes sense? All right. So that's how this keyword works. It automatically gets created for us, and it always points to an object from within itself. And why do we need it? It's because if I want this object to be able to talk about himself inside of himself, I don't have access to this variable either L or L2 inside of those objects. Does that make sense? So that this keyword gets created for us so we have some way of referring to ourselves. What if you lost that ability? Okay, for in real life, what if you could never refer to yourself? Yeah, that would make a lot of conversations really awkward, right?
You just say.
If you lost access to talking about yourself. That makes sense?
You can't say I, you can't say me.
Yeah, can't say I, can't say me.
Those just the two.
All those things are can't talk about yourself. Right? So it becomes pretty debilitating, right? Mm-hmm. Okay, that's why we need it in code. All right, so does this keyword make more sense now?
Question.
Go ahead.
So then how do you use the this keyword in the static
context? You can't.
Okay.
Yeah, by definition, this would not exist in a static context because this is how an instance of an object refers to itself. If you're in a static context, that by definition means you're not in a non-static context, which means you're not in an instance context. Therefore, you have no me to talk about. There is no instance. Okay. So back over here on the Android side, and again, the stuff that we're looking at here, even though we're looking at it in the context of Android, this is just normal programming stuff. this and self are synonyms. So the self you learned about last semester is the same thing as the this that we just learned about here. Is that this is this guy right here. And what are we referring to? We're referring to this particular instance of main activity. So I'm saying I want this particular instance of main activity to set his content view equal to this dude right here. I'm going to talk about this R thing in a second, so just let me slide on that for a second. All right. Similarly, where I was making my connection before was the MVC thing. So I'm saying here that I want to take this guy here. I created a little widget. I have a text view in my app. I happen to name that guy app name TV as opposed to like this guy down here. He has a very generic name like text view 8. Okay. So if I'm going to need access to that guy and I want to manipulate him from code, I probably want to give him a name a little bit better than text view 8. But if he's only there for show and I'm never going to actually programmatically access him, he's just for looks only, I can just leave it as text view 8. That's fine. That way you don't waste your time naming every single little variable or every single little widget on your screen. You only need to give meaningful names to the ones that you intend to programmatically use. All right, so I named this guy app name TV. That way over here in the controller, because remember this is MVC, model view controller. So forget about model for a second because we're not doing data storage yet. But the view is this guy, that's my interface. The controller is my code behind. And if I need to refer to things from either side of that, I need to have some way of connecting them. So my way of connecting it here in Android is by naming this widget something memorable in here. And then in code, I can then create a variable of the same type. So I'm going to create a text view. I happen to name my variable the same thing as I named my widget because I named my widget that for a reason. Right? So it kind of makes sense. I'm going to use I used a meaningful name for it out there. I'm probably going to use that same meaningful name for it in code. Not a requirement though. All right. I could have named this guy Elephant if I wanted to, but then we wouldn't know what we're talking about. All right. So this is going to be my app name. And I like naming them with a TV at the end of it for a text view. TV, text view. Get it? So then you kind of self-explains what it is. That's more of a, I mean, you'll find other people who name things like that, but that's just the way I've named it over the years. I don't know if I came up with that or modeled it after something else when I was learning it and adapted it. I don't remember. All right. And I'm going to, in order to connect the dots here though, I need to use this particular instance of main activity to go and search for that widget. So I'm going to say this dot. So I'm asking my current instance of main activity to go on a hunt. What am I searching for? I'm going to find a view given its ID. And the ID of that guy that I named was app name TV. I named it that over my interface. That makes sense? Okay. And then I have access to it out here. And just to show you what I can do with this, I can then say app name TV.set text to LOL. So this is on create. So this is happening before your app even shows up on the screen. All right. So even though out here, the name of my app says my first app, before it even appears on the screen, I'm going to give myself programmatic access to that text view. I'm going to change the text to say LOL. So when I actually launch my application, I'm going to launch my Pixel API 26 Daily guy here. You'll see that the app name, this is the app from our 325 class. It'll pop up in a second. Still executing it. Go ahead.
Is there any benefits of changing, like doing programming in the control versus doing the view, like changing it in the view?
Probably not in this case. Okay. This is more just evidence that we can connect it to. Although there's going to be plenty of examples of benefits where you might want to have read something in from an input box and do something with it and put the answer out on a text view,
Okay.
something like that. So tons and tons of benefits, but our example here,
Yeah.
not a great one. Yeah. So now notice it's up on the screen. It says LOL. So even though I wrote it to say my first app, because I connected it to my code, and when my activity, when this particular screen was created, I went ahead and grabbed that text view and set his text to LOL. He's now been changed, proving that I have those two linked together. Make sense? All right, so this is how Android accomplishes MVC. So remember, the idea of MVC is it's a good idea to keep your data, your view, and your logic in, or your data, your interface, and your logic in separate places, so they don't kind of create big messes over each other. But if you're going to separate them, now we need to have some way to situationally bring them back together when you need to. This is how Android does the MVC for giving us access to widgets on our screen out here from within code. This is how I gave myself access to that widget. Okay. Now, I'm going to go, well, actually, let me talk about something here real quick. We have this class here called R. All right. And I think I had in the notes of our starting point. What is the R class? So the R class is automatically generated and updated by Android to provide a list of available layouts, widgets, etc. So this R class is part of their implementation for MVC. When you do something in the interface, it automatically gets added to the R class so that we can access it from within the our code. And R is automatically updated for us. So whenever we make a change on the interface, Android automatically updates the R class. Okay. So this is an Android specific tool, but it still follows the rules of all of our other programming stuff. So what I have highlighted right there, ID, what kind of animal is that? Field, constructor, or method?
Field.
How do you know?
There's no parentheses.
No parentheses. Okay, is it a class field or an instance field?
Class.
Why is it a class field?
R is a class.
R is the name of a class. Good. So just a minute ago, I told you that R is the class name.
Yeah.
Android maintains this class called R. So if I'm saying the name of the class to call upon this member, that must mean that ID is a static field. Okay? And then this guy right here is a, well, we don't necessarily know if this is an instance or not. It's actually neither. This is a int. So this is a really fancy way of boiling down to just a number. So this guy r.id.appnametv says, give me the unique integer that was generated for that particular view. That way I don't have to remember that this guy was actually view number 17,241. Make sense? Now I can refer to it like this. Go ahead.
How do you know that the r.id whatever is an instant? I mean is a integer?
If I start typing it here, r.id. Notice these guys are all ints. Just tells me what it is. Yeah, I'm just telling you that's the type that it is. You couldn't have necessarily inferred that by just looking at it. Yeah, notice the value it has. So it's a hexadecimal value. So the value of app name TV is 0x. Well, that says it's hex. So 7F07001D. Everybody have that memorized?
No.
Okay. So if we have that memorized, then we no longer have to use r.id. So I can just type that in. So we can prove that. 7F. Somebody write it down real quick. 7F0. 701D. 7F0 701D. Okay. And I need to write it like that. Is it not gonna? I'd actually need to convert this to its. Let's do it. Too big. Yeah, it wants it wants a type. It's specifically going to give me a, well, no, it wants an int. I gave it an int. We'll just really convince him it's an int. All right, it's an int. All right, so now let's make sure we can change that to LOL. There we go. Far easier, right?
Yeah.
Yeah, so this is a much easier, instead of saying r.id.appnametv, it's just easier to just put in, what is that? 2,131,165,213. Do we get the purpose of the r.id thing now? All right, so r.id.appnametv. All right, makes some reasonable sense. All right, so that's what that R class is for. This is how we do this stuff. So now I'm going to show you the other direction. So at this point, we've provided a widget out on the screen, and I wanted to give myself access to the widget inside of code. So now what I want to do is I have a button on my screen. I want that button, when it's clicked, to call a function in my code. So I need to let that button know about code. Instead of, in this example, I've let my code know about a widget. So I'm going to write a function here. So we're going to say this guy is public void. Let's call this guy LOL button pressed. And he's going to take a view. V is a parameter. Now, when you actually type it in here, if you just start typing in view, press enter after you have the view entered in, because that way it'll import it up here. Otherwise, it'll say it doesn't know about it, and you'll have to go and import android.view.view to make it available to you. And then what I'll do in here is I'll actually just grab my code from up there, and only when we press that button, the LOL button, do I want to go ahead and grab my text view and set its text to LOL. Okay. Now at this point, what I've done is I've written a function that could be called if a button was clicked. And this function for Android, this is again MVC for Android, has to be public. It has to be void. We can name it whatever we want. It has to take a view as a parameter. You can name that parameter whatever you want.
Question.
Yep.
Is it a view as a button?
Well, a view is anything you can see on the screen.
Oh.
So buttons would be examples of views, but there are also more. All right, so this is called a callback function. This is the function you want to have your button call when it's clicked. All right, so it must be public, must be void, name it whatever you want. It has to take a view as a parameter. You can name the view whatever you want. All right, so I've saved this code. So now what I need to do is I need to let my button know about this guy. Where in my previous example, I let my code know about one of my widgets. I'm going to go into my design. I'm going to click on my LOL button. I see a drop-down thing here that says on click. When I hit the drop-down, there's my LOL button pressed function that's there. But it's only going to show up there if you write that function the right way. Okay, it's got to be public, got to be void. Name it whatever you want. Has to take a view as a parameter. You can name that parameter whatever you want. If it doesn't show up as that, it won't make this list. So I'm going to select that. So remember, now I am no longer changing my text view inside of onCreate. So when my app first launches, I'm going to go ahead and I'm going to see what was my text, my first app or something, my first app up there. And only when I click LOL will I see a different, will I see LOL show up there. So I'll go ahead and run this. There it is my first app initially. Then I'm going to click this button, which has an on-click attribute to call my function. And when I click that, it changes the thing to LOL. That makes sense?
Mm-hmm.
All right. Now, let's say I change the text on this one to be woot. And I change the text on this one to be Blaine. Okay, so we have Woot and we have Blaine for our buttons. So now what we can do is we can go and write similar functions. So I'll copy that guy. We'll paste it again. I'm going to just follow my naming convention here. This is going to be my Woot button pressed. This will be my Blaine button pressed. All right, and this one I'll change the text to Woot. This one I'll change the text to Blaine. Then out here, I need to let these two buttons know to call their particular functions for on-click. So I'll click on Woot. I'll go to on-click. Notice that all three of those functions show up there, so I'm going to choose the one that says Woot. Then I'm going to click Blaine. On click, I'll choose the one that says Blaine. I'll go ahead and run this, and now we'll see that all three of our buttons work. So there's my LOL, there's my Woot, there's my Blaine. All right. Now, if I want to take it one step further, I'm going to create a public void some button was pressed. And what I'm going to do here is I'm going to say button B is equal to, so as I'm typing in button, see how it showed up as red? So when I get to the end of button there, press enter, and that'll go ahead and import it for me. So I'll say button B is equal to the button version of V. So this is going to tell us what this parameter is for. So this view V that comes in is the widget that called upon this function. So I happen to know that I'm only going to attach this to my button. So I know that V is going to be a button. Then what I'm going to do, get it? So I'll go ahead and grab my text view. Then I'm going to set the text in here to b.getText.toString. So I'm going to set the text of my app name TV to whatever text is on the button. That makes sense? So this will allow me to have a single function for all three of those buttons. So I'll go back into my code here. I'll click on LOL. And I'm going to change his on click to the sum button was pressed. I'm going to go to Woot. I'll change his button to sum button was pressed. And I'll go to Blaine, and I'll change his on click to sum button was pressed. So all three of these buttons now call the exact same function, but when they call the function, they pass themselves in as that parameter, that view V parameter. So now when I run this, it will grab the button that called it, take the text off that button, and put the text onto our label. So there's my LOL, there's my woot, there's my Blaine. Now we actually see something interesting here. Even though this LOL is showing up in all caps here, that shows that buttons actually show their text in all caps. Woot we wrote in all caps for this text. Blaine we wrote in all caps. But this LOL here, we come in here, we'll see it was actually written as all lowercase, LOL. All right, that makes some good sense. All right, so for your homework for Thursday, recreate this. You can make your buttons say different things if you want, but I want 3 buttons. You can have 3 separate functions that make it work, or you can have 1 generic function. Doesn't matter to me. Okay, but I want you to recreate this. Now, what I'm going to do as a starting point here is I'm going to import this into version control. So I'm going to share this project on GitHub. Now I'm going to teach you about GitHub next class. But I'm going to share this on there and give you a link to it so at least you can go back and refer to my code conveniently. Okay? So don't worry about the use of GitHub yet. Just know that this will give you access to my stuff. All right, so this was successfully shared on GitHub. So here's the link for it here. So all my code is in here. If you go to app, then you go to source, then you go to, I think it's this guy. No, it's not that guy, it's main. And then this guy, there's my main activity.java. You can see all my code in there. Go ahead.
Are we doing stuff in our Blackboard?
Yep. So what I'll have you submit is just a picture of your running app.
Okay.
For this one.
So do you want the code too?
How about a picture of your running app and a picture of the code. In the future, when I teach you GitHub, you'll just give me a link to your GitHub. Yeah, so it'll be easier moving forward. But what I'll do for right now is I'll just go into CSC250 and I'll paste this link. So that's the link to our current code, so you have something to reference as you're recreating it. But what I really want you to do here is don't do a lot of copying and pasting. Type it yourself. Get used to doing these different moves of MVC on both sides. Okay? That'll get you used to using the tool. Questions, comments, concerns, bribes. Remember, one second. Remember, today is student, faculty, staff, Bible study, God and grub. Go to the cafeteria, sign in, take your tray down to the terrace room. Also, tonight, there is a grace meeting. I think it's in this room or it's in the fishbowl. Maybe it's the fishbowl at 7 p.m. tonight. I will be giving a talk on blockchain technology. So I invite you to come.